This is for Year 12 Specialists. It comes out of AD. The lengths of curves is number 7. So I have a parametric equation happening here. So I'm going to be using this rule. So I need to take some derivatives. So dx dt will be 1 minus the cos of t, and dy dt will be sine of t. And if I'm looking at this squared, it's going to be that squared and that squared. So 1 minus the cos of t squared plus the sine of t squared will give me 1 minus 2 cos of t plus cos of t squared plus sine of t squared. This will equal 1. Therefore, I've got 2 minus 2 cos of t. Now, because it's perfectly symmetrical, the length can be the integral from 0 to 2 pi of the square root of 2 minus 2 cos of t dt, or it could be 2 times integral from 0 to pi of the square root of 2 minus 2 cos of t dt. Doesn't matter because this will be half the distance because I've got some symmetry happening there. So if I consider this as being the length is 2 lots of the integral from 0 to pi of root 2 times root of 1 minus the cos of t dt, I've got 2 root 2 integral from 0 to pi, the square root of 1 minus cos of t dt. And now I've got to work out how to integrate this thing. Now I've got 1 minus the cos of t. I can't use the u substitution because I don't have the derivative of the inside, which would involve a sine of t. But what I might like to do is I might like to use this and try and do a substitution that might work nicely. So I've got 1 minus the cos of t. And I know that the cos of 2t equals 1 minus 2 sine squared of t. Oops, which means if I made this negative cos of 2t, so I'm trying to build up this, that should equal 2 sine squared of t minus 1. So I've just multiplied by negative 1. Now if I add 1 to both sides, I'll have 1 minus the cos of 2t will equal, if I'm plus 1 to both sides, that will cancel that out, 2 sine squared of t, which means if I had 1 minus the cos of t, since this is a double angle formula, it's going to be 2 sine squared of t on 2. So I can come up here and do a replacement 2 root 2 integral from 0 to pi of the square root of this. The square root of 2 sine squared of 2t on 2 dt, which will be 2 root 2, 0 to pi of root 2 times the sine of t on 2 dt. And the root 2 can go out there and have 4 times 0 to pi of the sine of t on 2 dt, which will be 4 times the integral of sine is negative cos of t on 2, and I needed a half, so there's a 2 from 0 to pi. So I've got 8 times minus the cos of pi on 2 plus the cos of 0, which is 8 times 0 plus 1, 8 units long.